Measuring the decision time of an algo server isn't that straightforward, purely because you have many inbound market data ticks, and we can see here the message volumes are quite high, and in response to market activity a decision will be made to place outbound orders. So we can see here that the frequency of the outbound orders is much less than those inbound ticks. Now, correlating the two together also isn't easy because there's usually nothing in the outbound order that you can relate back to the inbound market data tick that triggered the event. So in order to do this, Corvil will monitor all of the ticks coming in to the server. It'll monitor all of the orders going out, and for each one we're recording an accurate timestamp. Now, once that decision has been made, the server can then publish onto the wire a correlation message that contains a piece of information that relates the outbound order to the inbound tick. And Corvil picks these up and can then retrospectively do a three-way correlation to relate the outbound order with that inbound tick. And because we stored the timestamp for each message, we can then work out the decision latency of the algo. So let's take a look and see how that actually works at the message level. Now, at the moment, we're tracking in real time some outbound orders, and we're seeing the latency of those orders in real time, so tracking about 18 milliseconds. So all I'm going to do is just select one of those spikes, and I'm going to click Analyze, and this is going to launch us into Corvil's event analysis window, where we can take a closer look at those messages. So we can see some examples here. I'm just going to pick the first one, a new order single there with a latency of 11 milliseconds. Now, if I click on the little black triangle to view the related messages, it'll show us what it's correlated it with. So the new order single here has been correlated with a market data incremental refresh in the CME market data feed. Okay, now to work out how it's actually glued those two together, I can click on this little expand button here, and it'll show us the correlation data that was published as an LBM message that was picked up off the wire. So just to step through this in a little bit more detail, I'm going to open up the full message content on the right hand side, starting with the new order single. So we have the fully formed order here, and within this we have a message sequence number of 840. Now, if we then look at the LBM message, we can see that it contains two fields, that order sequence number of 840, and it's also got the market data sequence number of 1131211. So if we then go and look at the market data tick, we should indeed find that it has a message sequence number there of 1131211. So by using the three messages, Corvil was able to correlate the outbound order with the inbound tick and calculate the latency as being 11.76 milliseconds.